Yo guys, welcome back to this series on serverless. This is part 4, and in this one we're going to be diving a little bit further into things, creating our put route, creating our get route, fixing up the CloudFormation stuff, making it a little bit more production ready, and same with the code base, right? Adding that put route in, working with the database a bit, and messing around with a little bit with environment variables. So first things first, though, in this output section in the template, I want to change a couple of things here. Just make that a little bigger. So down here we have some outputs from this CloudFormation template, right? This is going to be a stack once it's created, and what an output does essentially is allows you to export a resource from a stack and have it importable into another stack, right? So if I have an ARN or a resource or some ID or some value that I want to use in another template or someone else might want to use, I can export it and make it available in this output section. I don't really need to do that for these, but I will have this one here, which will just allow my API name essentially to be exported so that we can quickly see what it is and makes it quite easy to use. I'm going to remove that hello on the end and just leave it like this. This is fine. So this is our template so far, but I want to have two functions. I don't want to just have a single function for this app. I'm going to have two. And of course, you can have one and have two different events that trigger that same one if you'd like to. Even with different methods on different routes, whatever, you can have one with heaps of different events that trigger it, or you can have multiple with single events. So just up to you. Think about scalability, and also think about, this is so modular, right? I mean, if I have them as separate functions, I can even have one in a different language. I can have one with one can be written in Java and one can be in Node, which is incredible. But still form that same application, which is really cool. So what else am I going to do? I'm going to change the timeout from 3. I'm going to make that about 5 for local testing, just because it does cold starts essentially every time you execute locally. So we'll see the onset effect of that shortly. And so what else I want to do here? This one should be called our put function, maybe. This is going to be just for putting, and this one's going to be just for getting. Makes it nice and easy. The route for putting. So our API is going to be /tasks, right? That's what it's going to be. So our API name, which is down the bottom here, and then /tasks, because everything's going to be a task in this app. And then curly braces to indicate what we call a path parameter. Now, path parameter is essentially a variable that could be passed in by that app or that user, whoever's using the API, in this specific position in the path. So /tasks, and then whatever they put in here would be inserted into the event as a parameter. So I want to call this task ID. So this will be the ID of the task that you want to put into the database in this specific aspect. And the method, of course, should be a put. And we can copy paste this down here and change the method to a get, right? Because this is our get function. So this is looking a bit better. One thing though is I don't want to have these in the exact same function. I'm going to make two separate functions, and one function just solely for putting and one solely for getting. So my function is going to be called put task for putting and get task for getting. And that'll be nice and clean to separate those. So one last thing I want to do in here is I want to put in some environment variables. Now, the reason why I want to do that is because if you quickly just jump over to the app.js, this is just one thing I've added in here quickly, and it makes a bit more sense. And I haven't added anything else in here, just this. But this is essentially taking away the hard-coded strings that we had in here for the region and for the endpoint, and replacing those with environment variables, because it makes sense, right? I mean, this AWS_region environment variable is always available inside Lambda, inside a Lambda execution environment. And it always references the current region that you happen to be in, that Lambda is in, the regional, right? So DynamoDB endpoint should be an environment variable as well. If it is specified, it should be whatever it is. Or if it's not, or if it's undefined, or if it's not specified at all, it should be undefined, because undefined would be the default value, which would then talk to the regional endpoint for DynamoDB, which is what we want when we're actually in AWS, but it's not what we want when we're testing locally with Localstack, because we want to specify a custom endpoint in that case. So that looks good. So what we'll do is we'll add that in here. So I have a snippet for this. So using snippets, guys, I tell you, is just the coolest thing ever. So environment, tab, done. So this will add these two environment variables for all of my Lambda functions. So they will all have this value. They will have these keys, but they don't contain any values. right? And that's probably a little bit confusing. Like, don't you want to specify that here? I actually don't want to specify it here because these two values are only ever for local testing. In production or in like a dev environment or something that's actually running in AWS, I don't want them to be populated. So I'm just going to leave them unpopulated. But locally, I need to specify them in this template in order for them to be passed in from my current shell context into the Lambda function that will be running inside the SAM local side here on my laptop. So that's sort of a little bit tricky at first to get your head around, but you need to specify them here, even if they're blank, like you can put the value in here, but this allows them to be passed in as environment variables to the Lambda environment that we're going to be running locally here. So that's something we need to do. So I'm pretty happy with our template here. This looks pretty good. Our SAM definition, right, our serverless definition of our app here. What I want to do is jump over to the app.js and go through a couple of things here. So first of all, some crappy things we didn't do. I mean, you do need to do error handling properly, right? So I didn't do error handling properly here. I'm just returning the promise, and if the promise rejected for whatever reason here, we don't even return that. So this catch block that we created down here, it never would even catch the error at this point. So we need to catch, or like return an error, which we're going to do by saying .catch. And then we can maybe just log this out so that we can see that we got an error. Otherwise, we just really don't do anything, and we really need to do proper error handling. So that was our put for putting stuff in DynamoDB, see the put method here. We also need one for querying against DynamoDB. So that is a method called query. And the document client is super simple, right? You have your put, your query, you have all these like very basic bits of functionality. And they just take a params object, right, of course. And again, we want to return a promise. And if there is an error, we want to return the error from that. So we have our Dynamo query and our Dynamo put. We're going to use both of these. I don't know if we need response anymore. Let's remove that for now. And of course, we have this handler function, which is the main point of execution. But if you look at our template.yaml, we don't even reference it anymore. We say, yeah, this is going to run a function called put task, and this is going to run one called get task. So we don't need handler anymore, right? Handler is just a waste. So let's just rename handler to get task. This will become our get. And of course, we can still use the try, and we can probably change this x into get, right? Because x is just a crappy name for a variable. Just don't ever do that. And this will become DynamoDB query. And this is what a query looks like. You have this table name that you ask for some data. And you have an expression, right? And then you give the expression some attributes, some values. So in this case, I'm saying that the expression that I want to look for is ID. ID is going to be, of course, it's our primary key for our DynamoDB table. So that's the thing that I want to use to look data up, right? When I'm asking it for data, I want to say, here's the ID I need, please. Give me the value for whatever that is. So that will be fine. This will give back to us 1, 2, 3 every time, right? So that's not good. So let's just change that. So what we want to use here is this idea of this path parameter. So whatever the user puts in here is the thing that we want to get out of the table, right? We want to go to the table and get that specific thing. So let's add that in. So how do we know that's a thing? Well, if you look in the event, right, this is what's going to be available inside the Lambda execution environment as the event that's passed in from API Gateway. Path parameters is a property. And you can see it has a key for whatever the path parameter key was, and a value for whatever the value of that is. So we know that the value is going to be whatever the value is passed in by the user, but we know the key is going to be task ID. So what we can say is event.pathParameters, right? And then task ID. So this will give us, this will translate into, obviously digging through that JSON object to pull out the ID of whatever the user passed in. So because we're using JavaScript and because this is an event JSON object, and we can see if we look back that it looks like in the event, we have these strings here. But we know in our schema when we created our table, we said that the ID had to be an integer, right? It has to be a number. So what we should do is we should force whatever this is into an int. I think that's a good way to go because then we know we're at least asking the database or the table for the right type of value, right? We know this has to be a number. So that's probably a good way to go. And then what we should do is, rather than returning hello world, we can just return the get object, whatever was returned, back to the user. So you can see we're going to actually just pass in this value here back to the user. And we don't have response anymore. So what we can do is just directly do a callback here. So we can say that, hey, call back to API Gateway and say that there was no error indicated by the null, and that in the second argument here for the callback, which is what do you want to actually send back to DynamoDB, we're going to generate this object, and this object has to have a property called status code and has to have one called body. And the status code is going to be 200, and the body is going to be the get, like whatever was returned from the database, right? That's here. So it's very simple. So this is looking pretty good. We haven't done anything with 404s or anything yet, right? Like if there's nothing in the data, if nothing in the table, then we should 404 to say, yo, there's nothing in here. We haven't done that yet, so we'll get to that in a moment though. But this callback functionality we also need to do down here if there was an error. If there was some sort of weird error that happened, we should still call back to say there was no error in the Lambda function. Think about that first argument in the callback for Lambda functions when you're working with API Gateway as, should the Lambda function critically error and like bomb at this point? And in this case, we want to say that it should never bomb. It should always pass back something to API Gateway to say, hey, this is just crap, or I bombed and this is why. And we need to generate that response to tell API Gateway what happened. So we can say that it's a 500 error now, like that, hey, everything broke. And rather than putting the get response in there, we can put in the error object in there. So we are passing back something to say, yo, this didn't work. And we can get rid of this callback now. So this is our get task. We can clean up down the bottom here. We don't need this anymore. Rather than exporting our handler, we can export get task. And we can also export one called put task. Put task. And of course, we don't have that yet. So let's copy and paste this whole thing. Change this to put task. A lot of this is going to be very, very similar. Rather than having the Dynamo query caller, we have our Dynamo put. You still need to pass a table name, but you don't need to pass this other stuff. You just need to pass in what item that you actually want to put into the database. Now, what item do we want to put into the database? Well, we want to put in an object, right? And it has to have an ID. So what would the ID be? I think the ID will be this, right? This is always what our ID is going to be, because you need to specify a path parameter when you're putting something into the database as well as when you're getting something out. And that's a pretty good way to tie these two together, right? You have to say, you ask for the exact same thing that you get for. So what else do we want to put in? Let's put in a task. What is it actually that we want to store in here? And this should be in the body of our event. So if we look in our event, you can see there's a such thing as a body where you actually pass in a whole JSON object that you can manipulate and you can use on the back end. So in our app.js, what we could say is that, well, first of all, we should take this in. So JSON.parse, we want to parse it as JSON because it's going to be a string when it comes in from API Gateway. So event.body, that gives us the JSON object. So let's just say body equals JSON, like that. So then we can actually parse this and we can like use a dot to actually traverse the tree. So the task, so body is going to be, and then task, right? And then what we say is we'll put a JSON object when we perform our put request, and that will have a property called task in it that will go in here. And we want this to always be a string, right? This should be a string for whatever reason. We just want to always store the task as a string. And then we could say complete, maybe complete. I don't know. Is the task complete? And this will be in here as complete, which will be a what? Boolean. All right, so I think that's probably all we really need to store in the database. It's probably a good way to start. And of course, if we do put something in, we can return, this is just going to be, so what this is going to return is a empty object if there is no thing to put in there. So I mean that's an okay response, really. I mean we can make this say okay, maybe. If that's what you want to do, that's also fine. But if there was an error, we should 500. That's pretty straightforward. So this is probably good enough to get going with. I'm pretty happy with this. We've changed quite a bit. So let's go ahead and test this out. So what we can do is we can do that quick query against our table, and we can see we have nothing in our table, right? We're using the AWS local here just to look at our table in Localstack. And if we have a look at our Localstack, you can see that I just spun it up. It's been up for 45 seconds. But one thing I did need to do is I needed to make a Docker network and create Localstack in the same network that I'm going to be using my SAM local environment in. And that's because I need to have the communication between these containers and also anything that I want to execute against, right? I need to be able to say, reference just Localstack, the name, and maybe a port, and then have that from my app communicate with this specific, these specific Docker Compose file that's created these ones. So I need to make sure that they're in the same network. So I've created this here. So if you have a look at Docker network inspect, you can see that the Localstack container is actually in this network called SAM. So, and of course, I'll make this available for you guys so you can check it out, but this is the Docker Compose file that contains the name Localstack, which is actually what we're going to be referring to it by, and also the SAM network gets created in here. So that is all well and good. So that's all up and running. So what we need to do is export some environment variables. So our DynamoDB endpoint is going to be called Localstack, right? That's just what we saw a second ago. We made it be called Localstack as the container name. So when we expose DynamoDB, it's going to be called Localstack, and then we reference the port for DynamoDB. And also a region, right? These are the two that if I specify them in my shell on my laptop, they will go into the Lambda context in running in SAM local, but only if you've specified them in here as potential environment variables. Keep that in mind. Otherwise, it won't work. And you could, of course, hard code them here as the actual values you want, but I'm just going to reference them from my shell. So that's, I think, everything we need to do. So we can say SAM local start API -- Docker network SAM, right? And that's really important, like we said, because we want to start this in the exact same Docker network as Localstack to be able to work with DynamoDB. So everything looks like it's up and running, so we can open up Postman, and I can say copy and paste this, paste that in there, and I can run a GET request against task number 1, right? I don't have a task number 1, I don't have anything in the table, but we can still run it, and that should give us something. So here that gives us a response saying that there was no items, and there was a count of 0. In this, we have the get object here. So that's maybe, that's not what we really want for a 200, right? If there's no items, we should get a 404. So let's quickly add that in. So what we can say is that if, this is in our put, so forget that, it's down here. So we can say that if get.count, right? So if you look at the object here, there's a property called count, and it contains the amount of items that were returned. So if count is equal to 0, then we're good to give a 404 because we didn't get anything. So we should just give a 404. Null 404, and we can just say here like not found. Maybe that's good enough. So you don't actually need to reload SAM or anything. You just change the code as you like, and then in here you just hit run again. Really as simple as that. You only need to reload SAM if you change the template.yaml, if you change your definition. So now we get a not found, 404 in status code, which is perfect. That's exactly what we want. So that's looking pretty good. How about putting data in now, though? So let's go Postman, change this to put, and we should specify a body. So that's going to be raw, and it's going to be JSON application. So what do we need to specify here? We said that we need to have task, show task. So go fishing, I guess. And have we done that? So complete is going to be false, I guess. That should be fine. So that's going to become task 1. So we just put that in the database now. And loading, put. So I get a 200, okay. And I get this sort of like response here, which is a little bit crap, but we can change that later. And then now if I do a get, I guess I should get that data back from the database that I just put in there. That sort of makes sense. Loading, loading, loading. So it's doing cold start every time. Okay, so get items, go fishing. So we can see it's in there now. Complete true. Oh, because I put it in as a string. Yeah. So this is why you should use TypeScript, guys. Yeah, so because it was a string and it just parses it in there, it's going to, yeah, that's a nice JavaScript quirk. So I can put that back in there and I can just change this back to false. That should override it. So I'm putting something in over the top now. So this should just override this task. Just to sort of fix that up, let's just make sure that works. Get and Okay, so now it's complete false, right? So I actually pass in a Boolean in the JSON object rather than a string, which denotes to false. Anyway, you guys get the idea. Cool, so that's working pretty well. And if I do something against 2, which doesn't exist, we should get the 404. I can put something in. So there's another couple of things you can do here to make this a little bit more pretty. If you override a task, what you can do is use this thing called return values. And what this does is if you say all old, like what it does is if you overrode some value, like if you put in, I'll just show you guys. If I put in this same object now, but I change it to true this time, and we know it's in there as false at the moment. So if I put this in, oh, this is task 2, never mind. So this is just inserting a new one, but I'll show you guys what I mean. So we get that, okay, now that's officially task 2, so that's in. So if I change this to, like, I want to update it to go driving, what we get back is if we send that now, you'll get back the item that it overrode in the database. So you can, on like your app side, you can build in logic. So here I can see like I overrode this. I overrode go fishing that was set to true to go driving, true. So now like on the client side, like on the mobile or on the app or whatever, I can have like cool visualizations like you overrode this or whatever. So yeah, that's pretty much it, guys. So like, I mean, we've done a little bit of changes here. This is a little bit nicer. It's a bit more straightforward. We've changed it quite a bit. We've changed this quite a bit. I'll cut this one off here, otherwise it'll just go forever. And we'll pick this up in the next clip where we talk about where do we go from here. All right, cheers, guys.